Okay, before we move on to things like binomial expansion and combinations and other probability-based stuff, I wanted to quickly go over an introduction to factorials. Because oftentimes, especially when they come up in algebraic expressions, they seem quite complicated or quite difficult to use. So I'm going to explain why they're not. So first of all, what is a factorial? Well, a factorial is a number, say 4, with an exclamation mark after it. And what this means is you take the number that you start with and you multiply it by every number that has come before it. So 4 factorial is a 4 times by 3 times by 2 times by 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times by 1. And this is all a factorial is. Now, it will become apparent when we look at probabilities and binomials and things like that, why factorials are useful. But for now, I just want us to get used to using them algebraically. So, in order to help us do that, there's one thing I want to get across, which is the fact that if we wanted to write that more generally, we would say that n factorial is equal to n times n minus 1 times n minus 2 all the way down to 1. Factorials can only work with integers, so it's going to be from n all the way down to 1. And this is something very important, because we can also then note that n minus 1 factorial is n minus 1 times n minus 2 times n minus 3 all the way down to 1. And just these two statements here, if we remember these, make our calculations a lot simpler. So, for example, this is a very common statement to see in algebra, especially when we're doing binomial expansions and combinations. Now, a lot of people look at this, and there's a couple of ways they think about it. They either get really confused, like, I can't, how can I simplify a factorial? Some people try and cancel the exclamation mark, and none of that's going to work. So whenever you have to work with a factorial like this, there's one clear thing we need to do, and that is to write out, not the full expression, that wouldn't be possible, but a generalized version of what's going on. So what's going on the top here? Well, n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. Yeah? And then n minus 1, as we showed earlier, is n minus 1 times n minus 2 times n minus 3 all the way down to 1. And what we notice is because we just have a bunch of multiplication on the top and a bunch of multiplication on the bottom, stuff starts cancelling. N minus 1 cancels with n minus 1. N minus 2 cancels with n minus 2, and so on. Everything here will cancel down to the ones, and you are just left with n. And this is a much simpler way of working with things. It makes it a lot simpler, because when we have loads of multiplications, we can cancel. If this was in a very similar vein, n minus, or n factorial divided by n minus 2 factorial, same thing. We just want to write out as many of these as possible. And then see what cancels. And in this case, everything after n minus 2 cancels, and I'm left with n times n minus 1. Factorials are not hard to work with. They are very, very simple. But a lot of people get scared, especially when you've got something that looks like this. And hopefully soon we'll be able to see how to deal with this. If this video helped you, if you wouldn't mind subscribing, that would be great. And yeah,